Alright, this is Algebra 2, Section 6.6. Function operations. Alright, so another way that we can write equations is to write it in function notation form. For example, we have a f of x let's say equals 2x minus 1. You know, what's f of 2? Alright, and then wherever we see an x, we substitute with 2. F of 2 equals 3. So with function notation, we can do various things. We can add them, we can subtract them, we can divide them, and we can do something called composite functions, which is things that you'll be doing quite a bit in pre-calculus, calculus. In terms of adding functions, you can write them like f plus g of x, and that equals f of x plus g of x. You're just adding the two equations together. F minus g of x, which is f of x minus g of x. You have f times g of x, which is f of x, times g of x, and then you have f of x, f divided by g of x, which is f of x divided by g of x. Of course, given that whatever g of x is doesn't equal to 0. Okay? We can add them, divide them, multiply them, subtract them. And do composites, and we'll do composites in a second. Alright, so here they give us that f of x is equal to 2x squared plus 8 g of x equals 2x minus 3. So when we add it, it's going to be 2x squared plus 8 plus x minus 3. Alright, and then simplifying that, it's going to be 2x squared plus x minus 5. So this is what happens when we add them. When we subtract them, it's going to be 2x squared plus 8 minus whatever g of x is, x minus 3. That's going to be 2x squared plus 8 minus x plus 3, which is going to give me 2x squared minus x plus 11. That's plus 5 up here. My fault. Plus 5. Okay. just note that when you're subtracting one function from the other, the function that's being subtracted, you have to put parentheses over the whole expression, and you're going to subtract all of them. So you're going to distribute that negative to both of those. That's why you got the negative x, and the negative times the negative gets you the plus 3. Using the distributive property. Okay, for the next problem, we have that f of x is equal to 3x squared minus 11x minus 4. G of x equals 3x plus 1. Alright, so when we multiply this, it's going to be 3x squared minus 11x minus 4 times 3x plus 1. And you're just going to use like FOIL. So 3x times 3x squared, 9x cubed, 3 times 1, 3x squared, negative 11 times 3x is negative 33x, negative 11 times 1 is negative 11, negative 4 times 3, negative 12x, negative 4 times 1, negative 4. Alright, we combine terms. So this to this, this to that. 9x cubed put that up here plus 3x squared minus 45x minus 15. Oh, this is x squared. My fault. Reset. 9x cubed. 3x squared. Oh, this is x. 11x. My brain's not working today. 11 and negative 11x. Negative 12x. Negative 4. Alright. So this gives me negative 30x squared minus 11x minus 4. There you go. So that's when you multiply. When you divide, it's going to be 3x squared minus 11x minus 4 over 3x plus 1. Alright, so you can use long division and stuff. But first, before you try that, you can try to do factoring. So using, the diamond method, I'll do it down here. What two numbers add up to negative 12 and then gives you multiply the negative 12 and adds up to a negative 11, and that would be negative 12 and 1. So when you set this up, it's going to be 3x squared minus 12x plus 1x, let's say x, minus 4. This side we can pull out a 1. Over here, you can pull out a 4, a 3x. And that turns into 3x plus 1 times x minus 4. So when I rename this, this is going to be 3x plus 1 times x minus 4 over 3x plus 1. These guys cancel, and I'm left with x minus 4. Alright, so we have something called composite functions. And composite functions are when two functions are combined, two or more, because you can have two or more. So let's say 2. The book says 2. I'll leave it at that. Two functions that are combined. And it's done in the way of f of g. So f of x, g of x. Or I've seen it done f of g of x, where that little circle symbol is called is a composite. So what happens is that with composite functions, and here's the key, you evaluate the first function, so whatever comes first. So it says g of f of x. Right, you're combining the two functions. So let's say the first function and here's an example. Let's just use this one. F of x is equal to x minus 5. G of x is equal to x squared. Okay. F, the composite of f and g of x is like this. You're going to do f of x first. You're going to evaluate it, whatever that is. So f of x is x minus 5. We're going to do that first. Alright, that's f of x. Then you're going to put f of x inside of x squared, inside of g of x. So g of x is x squared, right? We're going to replace x minus 5 with x. We're going to replace x minus 5 with x. So it's going to be x minus 5, replacing that with x, and then we're going to square that. So if we have, what is g of f of, the book says, -3, then I'm going to replace that x with -3. And that gives me -8 squared, which is 64. Here they ask, what is f of g of x? So that means that whatever is here, this is going to be evaluated first. G of x. G of x is x squared. That's going to be evaluated first. And whatever this is now going to go inside of f of x. X squared is now going to replace x. So it's going to be, to say, f of g of x, we're now going to say x squared minus 5. We evaluated x squared first. We're going to plug that into x for f of x and have x squared minus 5. So when we talk about f of g of -3, this is going to be -3 squared minus 5, which is 9 minus 5, which is 4. Alright, so here, this is a store is offering a 15% discount. So the way 15%, if you have 100%, and we turn it into decimal form, meaning we put it back to decimal spots, we have 1, right? And we can say 1x, because it's going to be 100% times whatever the amount of money is. We don't know what it is. If we have an 85% discount, or a 15% discount, that means that 15% is being taken away. So we're going to subtract 0.15x, because that's being taken away, and that gives me 0.85x. So if there's a 15% discount, that means you're paying 85%. If there is a 20% discount, that means that I'm paying 80%, or 0.8x. So I have a 20% discount and 80% discount. The first thing they ask you is to model taking the 15% discount and then the 20% discount. So I don't know why they have them both called discounts. So let's say that we'll call the 15% discount f of x. So f of x is going to be equal to 0.85x. G of x is going to be equal to 0.8x. So when we talk about evaluating 15% first, and then the 20%, that's going to be G composite f of x, because we're going to do the 15% first, which is G of f of x. Okay. So G of x, f of x is 0.85, so it's going to be G of 0.5x, right? And we're, I mean, not 0.85x. And we're going to plug that in, that 0.85x, we're going to substitute that in for x. Then G of x over here. So then that's going to be 0.8 times 0.85x. And that gives me 0.68x. So you're going to end up paying 68% with those double discounts, which means it turns into a you end up having 32% off. That's neat. For B, it's not going to be f of g of x meaning you're going to do the 20% first and then plug that in. So that's going to be f of the 20%, which is 0.8x. And now the 0.8x is going to go in for 0.85. And that's going to be 0.85 times 0.8x. And that gives you 0.68x. So in this case, there's no better bargain. They both give you the same discount. Alright. Okay. Alright, that's that section. Hope you have a great rest of your day.